All right, today's lesson is on dividing radical expressions. We've already done a lesson, if you want to look back, we've done a lesson on adding and subtracting radical expressions. We've done a lesson on multiplying radical expressions, and now we're ready for dividing radical expressions. All right, so the rules. Okay, rule number one is that we must have the same index. So just like multiplication, it's got to be a square root divided by a square root or a cube root divided by a cube root. In this video, we're really going to focus on square roots, but that's the rule. You can't have something that has two different indexes and divide them. All right, rule number two is that any denominator cannot have a radical. Okay, those are our two most important rules, that our denominator cannot have a radical when we're finished. All right, so we're going to look at the rule. Okay, so here's our property. Okay, so the property says that if we have a times the square root of b, and it's being divided by c times the square root of d, then we can actually do a divided by c, and then times the square root of b divided by d. As long as b and d must be greater than or equal to 0. So much like the multiplication rule, our b and our d, our numbers inside the radical, must be positive. And then in this case, we're going to, instead of multiplying, we're going to divide a and c, and we're going to divide both b and d. Okay, so we're going to look at a few examples, and I'll show you what that looks like. So here's example 1. And you're going to notice we're going to do a few more examples of this just because there are some different things that can happen that can make a difference. So let's say that we have the square root of 6 divided by the square root of 2. All right, now we don't have any numbers outside of the radical. So in that case, we're going to proceed to taking care of this part right here, which is where we change it to the square root of 6 divided by 2. All right, now if possible, we want to divide. Well, 6 divided by 2 is 3. So our answer becomes the square root of 3. We look at 3. 3 cannot be broken down, so there's nothing we can do there. So that is our final answer, the square root of 3. All right, for a second example, we have 2 times the square root of 10 divided by 3 times the square root of 2. All right, when we rewrite that, we're going to write our numbers. So we've got 2 divided by 3 on the outside times the square root of 10 divided by 2. Okay, again, we write 2/3, and then 10 divided by 2 is 5, so 2/3 times the square root of 5. 5 is a prime number. It can't be factored. There's nothing that can be pulled out, so that would be our final answer, 2/3 times the square root of 5. All right, for a third example, let's say we have a situation where we have, let's say we have 12 divided by 3 times the square root of 3. All right, so first of all, the first thing we want to do is we want to take care of the 12 divided by 3. And then we want to leave our square root of 3 on the bottom. So 12 divided by 3 gives us 4 over the square root of 3. Now, if you remember from up above, the rule said that we cannot have a radical in our denominator. So the way to fix that is to multiply by the exact same radical. So we're going to multiply by the square root of 3. So we're not changing the value because we're multiplying square root of 3 divided by square root of 3, which equals 1. All right, we're not changing its value, we're changing its look. All right, now on the top, we have 4 times the square root of 3 divided by the square root of 3 times 3, which is the square root of 9. All right, now we know that we can square root 9. So 4 times the square root of 3, and then the square root of 9 is 3. So our answer is 4 times the square root of 3 divided by 3. Okay, I know it seems a little bit weird, but the best way to get rid of a radical on the bottom is to multiply by itself, because that creates a perfect square that we can square root to get a whole number, and then that when we divide by, or we multiply that square root of 3 here on the bottom, we must also do it to the top so that its value doesn't change and only the look changes. So that would be our final answer there. Okay, let's do one more. So last example, example number 4. Okay, we've got 2 times the square root of 7 divided by the square root of 5. Now, again, we don't have any numbers in that. We only have one number in the front, so nothing is going to change there. 2 divided by 1 keeps it 2, so we're going to keep the 2 where it's at. But we have this square root of 5 on the bottom. Okay, there's nothing I can do. Dividing 7 divided by 5 won't change anything, so I want to multiply by the square root of 5. All right. Now, I keep my 2. The square root of 7 times the square root of 5 is the square root of 35. And then the square root of 5 times the square root of 5 is the square root of 25. Again, we're making that perfect square on the bottom. Okay, so when I rewrite, it's 2 times the square root of 35 divided by 5. All right, if I look at 35, really the only thing I can break it down into is 7 times 5, and neither one of those have a buddy where they could come out of the radical. So my final answer would be 2 times the square root of 35 divided by 5. I hope this gets you where you need to be. Again, just remember your rules. Rule number 1, you have to have the same index. And rule number 2, any denominator cannot have a radical. So make sure you follow examples 3 and 4 for that on how to take care of it. All right, thanks for watching the video.